Hello, my name is Jeff Berger. Today I'll be talking about client-server systems. This is for my 410 Database Information Retrieval System class. In computer science, a client-server system is an architecture model consisting of three parts: a client, the server, and a network. The client initiates a request which is carried over a network to the server. The server then replies to the request and the reply is carried over the network back to the client. In a simple two-tier system shown here, the server performs the database functions and the client performs the presentation functions, such as how the information is presented to the user. Business functions such as calculations can be carried out either by the client in a fat client arrangement or by the server in a thin client arrangement. There are issues with both arrangements. In a flat client arrangement, updating business functions requires updating each client individually. In a system with thousands of clients, this can be difficult, if not impossible. In a thin client system, scalability becomes an issue. As the number of simultaneous client requests to the server increases, the server can be overloaded, slowing or even stopping responses. In this type of system, the client performs front-end processing. That's so-called because it performs business functions and calculations closer to the input source. The server performs back-end processing, performing calculations and processes without direct interaction with the user. A solution to some of the issues that you have with a two-tier architecture is a three-tier architecture, also called N-tier. In a three-tier architecture system, the model consists of the client, the network, the database server, and an application server. The three-tier system stores the business functions on the application servers. This allows for easy updates of the business logic as it is stored in only one place. Scalability issues can be resolved by adding additional application servers that can be controlled using load balancers to distribute the requests across several servers, and I'll show a little more about that later. Again, like I mentioned earlier, front-end processing is the processing that's done on the client layers. And back-end processing is done in a three-tier system, would be in the application layer and the database layer. A major advantage of the client-server architecture is improved security. Security checks can be placed at multiple points in the system, including the client, the network, the application server or load balancer, and on the database. This would ensure that only authorized users or applications can access or manipulate the data on the end applications. The only possible disadvantage is preventing users that should be authorized having accessibility, but that can be controlled by a well-maintained security procedures. A disadvantage of a client-server system also is the potential for a single point of failure, which is highly undesirable in any system with a goal of high reliability and availability. In a client-server system, failure in either the network, the load balancer, the application server, or the database server could cause the entire system to stop working. They can be caused by hardware failures or by software failures, database corruption. They can be, the danger of this can be mitigated by using redundancy, which involves providing redundant software and hardware components. However, this may be cost prohibitive in many cases. One way to mitigate the risk in any information system is to have a complete disaster recovery plan. One part of this will include a backup system. Backup system is important for all information system, whether it be a single computer for home use or a large business system that could include thousands of computers. An advantage of the client server system is that the data backups should only be needed on the servers and not on the individual client computers. Since the data and software are stored on servers instead of the individual clients backing up the data, becomes much simpler. As I mentioned earlier, one of the nice things about a three-tier system is the scalability. You can add application servers in a system like I'm showing here. The client sends its request to the load balancer, and then the application servers can all have the exact same code on them, the same processes, and then the load balancer can choose which of the application servers to send the request to based on its load at that time. That helps to speed the system up when the requests get too high. One thing that uses a client-server system, an example here, is Google Docs. In Google Docs, you can create a document and put it on their web-based system, and then other people, it can be in your same community, in your same building, it could be all the way across the world. They can open up the documents, edit it, and then load it back up into keep it in the system so that multiple people can make changes to the same document. One of the things that is widely used in a client-server system is side scripting languages such as JavaScript, jQuery, Ajax, and VBScript. These languages can help provide a user-friendly experience by letting the system provide an immediate response to the user. It does not require a trip to the server. This works great for, like, you're filling out a form and you have to validate a phone number, an email address. It can check that those are in the correct format immediately. It can do spell checking with this. If you have a text box that you're putting text in, you can perform immediate text spell checking without having to go back to the server. This works really good for slideshows. And for like suckerfish menus, which are menus that open when the mouse hovers over them and then closes when the mouse is removed. Programming frameworks, they're kind of the foundation that software developers use to build programs for specific platforms. Frameworks are designed to decrease the number of general issues that programmers have in the development process. They typically contain a collection of libraries, and these libraries are a collection of code that save the developer time by implementing standard functionality that is needed for the application. The developer just calls a library within the framework to perform some task, and then they can use that code to do their process. Say they want to print something, instead of having to write hundreds of lines of code possibly just to do a print. They can do one line of code that's in the library, and it'll accomplish your print function. So that's it. Thank you for your time.